one of you guys wants to? I'll keep this, and you guys can reshare that.
This one? Is it on? Is it on? I don't need to test it.
Hello? 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 Yeah, what's
Can you mute it?
They can share this one. So, you can just like present your slide first, and I can just not do it minus all you're waiting. Sounds good. So this one work, right?
Yeah, it doesn't work. Yeah. Oh, it's only one. OK。好啊，那个什么，咱们就不好意思，就晚了5分钟10分钟了，所以说我们就马上开始。然后今天不是我来讲的，今天是 Calvin 还有 Calvin 他的那个Club Startup 也是他们自己组织的一个 non-profit 一个组织，非常好。然后呢，我就做个小的开场白，介绍一下 Calvin 还有各位同学，然后介绍一下今天为什么要搞这个讲座，我们主要的目的是什么。然后我就直接奔主题，因为今天呢都是高中同学多一些，然后还有一些初中同学，那我就直奔主题。高中同学呢，我自己没有在美国上过高中，但是呢这2年带了好多高中同学，我现在基本上知道美国的高中是什么样子。我在这也有家长嘛，那我自己是参加国内的高考的，那我其实很负责的告诉大家，其实我来看呢，其实美国这个高中生活要远远难于咱们国内的高考。我家是河南的，所以说我们是高考比较卷的一个省，但是我觉得在这边这个高中同学啊，其实要远远比我们那时候更辛苦。OK， 所以说呢，我想这个引出的主题就是说，对，就是说，在座的同学也好呀，你初中也好，高中也好，马上你要面对的就是说我们的这个大学申请，这是你下面一个很重要的一个人生目标。OK， 那这个里边最重要是什么东西？我把它简化起来，听起来好像很复杂，听起来你要准备3年4年的时间，但其实呢，这个你要是看清它的核心的话呢，其实很简单，就2部分。当然，你提交大学申请的话呢，要么呢是一部分是分数，很重要，你的 GPA 啊、SAT 啊、AP 啊，所有这些分数。除了分数还不行，这也是美国这个大学申请比较挑战的地方，主要就是课外的这些活动啊，课外的这些经历，对吧？那这2个呢都非常重要，我不会说有一个比另外一个更重要，都同等重要，这要求我们有一个非常全面的这样一个体现。所以说而且呢，如果你仔细想一想这个大学申请的过程啊，我为什么觉得这2个都很重要呢？因为你看现在这个大学申请的人都很多，就今年过去这2年，像这个 UC 啊这些学校可能申请的人都超过10万呀，有的好像15万，我觉得特别多。那你面对这么多申请人，他可能每一年只录取那么1万人左右。你想想，你作为一个招生办的这样一个工作人员，你怎么去筛选？其实很难。所以说这里面一定要有方法。我觉得这个方法其实很简单。上去第一步肯定是先看你的分数。10几万人没有必要说去把大家所有的这个申请人数都要去读一遍，读完一遍其实也很难去做出一个筛选。对，所以上去的话，我会首先把这些好的分数呀，有好的学校的同学先拎出来，这样就够我去仔细去分析了。所以说分数之后的话呢，就要去仔细看你这些所有的这些背景呀、课外的经历啊，或者所有的这个东西。所以说我是说这2个同等重要，因为你分数不行的话，可能这个后边别人就不看你那些材料。对，但是你光有材料，光有分数也不行，因为到时候可能真的你帮助你脱颖而出的可能还是分数。对，所以说就是我看今天来很多高中同学呢，就是一定要注意 GPA 啊、成绩啊很关键，然后呢在这个基础上呢多增加一些成绩。所以我今天借着这个Calvin正好多说一下，就是说成绩上啊能出现能做哪些东西那我是做计算机的，我就给大家分享计算机方面的成绩。其实这个成绩呢，就是我要建议大家说要把握好这个方向和目标你其实做什么都可以。体育啊、文艺啊、计算机啊，什么都可以。但是最终的话呢，你呈现出来这些成绩呢，最好要落实到我说的这几个要素。OK， 就是你摆出来这个东西呢，尽量当然是有含金量，这个大家都很清楚。有一些竞赛比较难，那这个大部分同学没有，那这就是一个非常好的成绩。此外呢，这个成绩一定要很客观，就是不是你自己在讲，不是说我自己说我很喜欢 比如说编程，我很喜欢这个创新，我很喜欢某些动手的东西，机器人等等，而是说我到底得到了什么样的成绩和结果，要摆客观的这种成绩和事实，这个是一个关键。另外的话就是这个东西尽量是要独特一些啊，就比如说以 club 为例，可能大家在学校里面都参加了一些具体的 club，但是你像Calvin他们自己组织了自己的 Starline 这种 club，那组织的人就是比较少啊，我觉得这种unique 的东西会比较有意思一些。那最重要的话呢，我觉得成绩归成绩，最终还要落实到一个真实的一个经历中间去，它不是说纯粹是为了达成你来做这件事，你一定要有自己的一些感受呀，自己的一些经历啊，所以说真实性我认为非常重要。你只有真实的话，我觉得才能打动别人，对吧？所以我就简单的总结一下啊，就是我认为高中阶段大家这么忙的前提下，如果你想在计算机方面取得一些成绩，到底有哪些？其实就这3个东西，没有那么多了。就是只要能把这3个能掌握好，就是非常好的结果。哪3个呢？第一呢，从最简单来说，这个 AP 的计算机考试，AP 考试大家都很清楚很多门数 ，OK，20多门课，计算机里面占2门所以说也能看到它这个小小的一个重要性。这一门叫做 CS Principles， 还有一门呢叫 CSA。那Principles 相对来说简单一些，主要是概念，然后呢 CSA 呢主要是考试这个 Java 对这个编程的这个要有一个很扎实的这个要求。OK， 所以说这个 AP 呢，我认为算是一个小的成绩，因为大家都知道这 AP 呢，它是一个这种标准化考试，那个全国同学都考。我们加州你如果考5分，纽约的同学考4分，那其实大家就能看出来，其实你的水平更高一些。所以就有点相当于这个 SAT 的这个意思。所以说这2年有的学校可能不看 SAT 嘛，还看 AP 的成绩，所以大家就觉得这个东西确实有一定的这个说服力和这个参考性。所以我认为 AP 就是一个很好的成绩。那大部分同学学校你们都有这个课呀，不一定是1门还是2门的，最好把这个东西好好的落实一下。而且要是考的话呢，尽量去考5分。一会儿让Calvin和他们的这个伙伴们一块分享一下，就是他们怎么去考这个成绩的。第2个成绩的话，就是USACO 这个经济学的奥林匹克竞赛，这个很多同学都听说过是一种这种很类似于奥数的这样一个计算机的一个比赛，需要做题4个小时做3道题，然后有不同的这种级别，从这个红到银到金到白金，还有再往上面到一个这个整个美国的这样一个集训队吧，最后选出一个国家队。所以这个竞赛呢很难做题，但是呢，只要说你愿意投入时间，愿意比较扎实去练这个题，其实最后大家都是能够取得一定的结果。所以说，就是因为这个竞赛比较难，我觉得这个竞赛呢，它从含金量来说呀，从这个独特性来说都会比较好一些，肯定不是大部分都会有的。但是呢，这个就是一定要落实到最终的这个自己的这个学习啊，和刷题练习要投入时间。所以这是第2个成绩，就是你计算机水平比较好的时候呢，可以开始去落实这个USACO竞赛。第3个成绩呢，我就觉得是要把这个计算机应用到实处去，要做一些具体的这个项目出来，因为最终吧，学计算机学编程目的不是说为了掌握一个又一个的这种编程语言最终还是要做出一些具体的应用，做出自己的软件。这里边其实有很多机会，而且如果是你的这个应用软件做得很好的话呢，它能出很多成绩无论是说一些像什么科学竞赛的成绩，还是在难一些，比如说甚至有同学能发表出论文啊，能搞出专利啊，能把它拓展成一个自己的这个创业项目呀，就是你通过这些项目呢，其实可以落实出很多这种我所谓的比较客观、比较有含金量的成绩。所以这是第3个大方向。所以我总结一下，就是说，其实计算机编程其实听起来东西很多，对于高中同学来说，在你时间很有限的前提下。如果你想落实一些具体的成绩和结果的话呢，其实这个3个大的方向，第一就是 AP 计算机考试，第2就是 USACO 的这种信号赛的这个竞赛成绩，第3呢就是说和这个项目相关的一系列的成绩，好吧？所以我就说这么多。那今天正好有机会，就是 Calvin 现在是12年级 Senior University High School 就非常好的同学。我Calvin主要就跟他的这个 team 人一块会跟大家 share 一下，就是他们在这中间做这些 AP 做这些 USACO 做项目的一些经历和体会尤其是我觉得一些同学有什么有计划多跟 Calvin 他们交流一下，看看他们之前是怎么面对这个 challenge 我简单介绍一下 Calvin。我第一次见 Calvin 的话呢，应该是大概是在8年级前后的那个时间，我记不清是7年级还是8年级。那个时候呢 ，Calvin 数学很好，但是计算机我记得他没有怎么学过。当时呢，我们把Calvin放在那个Python 2，就是我们内部叫做一个进阶的一个课堂 当时上了几节课之后呢，Calvin觉得就是有点迷迷糊糊的。OK， 大部分内容能懂，但是呢，总觉得不是特别熟。OK， 自己去做东西呢，就觉得这个知道想干什么，但是不知道该怎么写。然后后来暑假就过去了，后来其实就过了一个暑假，到秋天后我又见到 Calvin 了。然后我们在上Calvin 说我想做这个 USACO 这个考试。我当时有点 surprise， 我说 Calvin， 那你这个开项目基础件怎么样了？这个能不能开始做这个题了？是不是要再需要一些时间再积累？他说我觉得可以了 ，ready 了。后来 anyway 就是我们就开始上了 USACO 的这个训练和培训，我就发现其实Calvin在班里面他确确实实很快，可能是那个班里面最快的一个还是2个，就是做这些难题的时候。所以课下我就非常 surprise， 我就问他，我说你这过了这半年暑假，到底你就去学什么东西了？怎么突然一下从最初当时Python 这个还不太熟悉，到现在就可以做 USACO 或者这些难题了。他跟我说这句话，我到现在我都记得特别清楚。他就说很简单，他说我 summer 的时候，我就利用夏天的时间把 USACO bronze 就是那个同级别的所有真题都做了一遍。这是他当时的原话，我现在还记在心里。所以后来我一直跟大家说，其实编程计算机这个东西其实从某种意义上和你平常做的这些 sports 体育文艺艺术都一样，它需要你投入时间，它需要你这个动手练习它其实没有那么多高深的理论的东西，其实是一个非常非常实际的一个学科。对，所以我今天来看Calvin已经12年级了，就是从他身上我能看到很多这些很好的这样一个过程，就是真的是拿时间和努力拼出来，其实跟老师关系就反而不是那么大，主要是是靠我自己的这样一个从零到有的这样一个过程。所以说，我觉得，而且我一定要强调，Calvin其实他应该就是在89年就是才开始做编程，到现在，其实你只要是投入这个时间的话呢，这个效果其实会很快的。OK， 所以说下面我就不多说，我就把时间交给 Calvin，然后之后有什么问题，同学就大胆和这个 Calvin 做交流就好。OK。Perfect.
All right, hi everyone. My name is Calvin, and I am the president and founder of Starline Education. And to my left is Jackie Bai, who's our vice president of communications, and Ian Parks, who's our vice president of development. And today we're going to be presenting pursuing computer science in high school. So we're going to be breaking down how we can pursue computer science to the best of your abilities. And before I like to begin, I'd like to say thank you to Dr. Sun. Without him, this event would have been possible. I'd also like to thank all my volunteers over there. They've done so much to help us and operate and do all this incredible stuff. So let's get started.
Let's do this and then do that. Yeah, perfect.
All right, so we're going to start off with kind of like a roadmap of where to begin. So in this presentation, we're going to start off by talking about the 2 AP computer science classes. So most of you guys have probably heard of what APs are. APs or advanced placements is a way for high school students to have a flavor of how college classes work. And so the 2 AP classes that most high schoolers generally offer is AP Computer Science Principles and AP Computer Science A. So we're going to be going a bit into depth about both of them, their distinctions, how they differ from each other, and how you can prepare and how both classes work. We're also going to be giving a nice logistical breakdown of how each AP exam works as well. And then next, we're going to be talking about AI and machine learning. So we're going to be talking about what resources you can use, what libraries you can use, how you can pursue it through summer courses and research. And next, we're going to be talking about the USA Computing Olympiad, which is what Dr. Sun was talking about, really prestigious competition. I'm going to be breaking down how you can utilize different resources to prepare for this competition, how this competition works, and all of that good stuff. And also, we're going to be talking about computer science and robotics. So we're going to be talking about all the different competitions, all the local and international competitions for robotics, how you can prepare, how everything works out in robotics. And then finally, we're going to be going through all the different competitions for CS. So I'm going to give you a bunch of different resources you guys can explore. In your QR codes, there's a link to this presentation here. And so if you scan it, you get all the links, you get all the resources for your own convenience. Just take a look and explore all the different kinds of competitions. We'll be breaking it down for you today.
Can you hear me? So first we're going to be talking about the AP science class. So we'll begin with AP CSP. It's a very beginner-friendly course, the intro to CS in high school. It's great if you have no prior experience, or even if you have a little bit of experience. It's non-hostile to that either. And it teaches the basics of programming, basic commands, how to write lines of code, how to use an IDE. And it talks about good programming habits and also about other applications of CS in the real world. For example, the digital divide, or even how the internet works. And usually as a part of the AP class, we'll do a final coding project that will submit to the college board for AP score. And usually it doubles as your score for the class as well. As the AP exam, it has a multiple choice section, which is 7 multiple choice questions that you take over the course of 2 hours. And this can cover everything from applications of computer science in the real world to digital divide to finding mistakes in code settings. And then there's also the performance task, which is a project that you'll be given 2 weeks in class to do, and where you need to demonstrate to the college board that you understand how to code. And that is 30% of the other 30% of the grade for the exam. This is a lot of text here, but it's just some really basic requirements that the college board has for you. They're not super rigorous. They're just the basics of code to make sure that you know what you're doing. And as long as you're paying attention in class, it'll be a breeze to do.
All right, so the next type of class that generally all high schools offer is AP Computer Science A. So this class teaches you the concepts and tools of computer science. Now, there's a really important distinction between this class and AP Computer Science P principles, and that AP Computer Science principles focuses more on the theory. So there are coding involved in AP Computer Science principles, but you also, like Ian said, you're learning about DNS servers, you're learning about the digital divide, you're learning about binary numbers. All these topics are involved in AP Computer Science principles. But in AP Computer Science A, we're going to break, generally what we're going to learn is just the programming aspect of it. So that's why it's taught entirely in Java. So in AP Computer Science principles, the class is taught based on whatever your teacher chooses. And in the AP exam, they're going to be testing you on pseudocode. So code is not actually a programming language, but rather code that's kind of like interweaving between like real life language and just coding in general. So it's not really real code. But in AP Computer Science A, it's just hard Java. So you've got to be able to understand how to write, how to utilize Java to do projects. And that is why it's harder for a beginner to jump into, because you're starting to orient your mind in a new and different way when you're a beginner and you've never learned how to code. So that's why the jump between just a beginner and computer science A might be a little bit harder than the jump from you as a beginner to AP computer science principles. And so that's why there are many projects throughout the year. So what I'd like to tell everyone is in AP Computer Science A, the best way to succeed is to do practice, is to apply your knowledge. So don't do flashcards, don't write out code in flashcards, don't memorize how to use the code, don't memorize how to write every single code. What you need to do is apply it to a project. So you can go online, search up on Google how to do Java programming practice. All right, you just do that, do a bunch of problems. In a similar fashion, you can make sure you do a bunch of projects throughout the year. In this case, you're going to be applying your knowledge and you're going to be able to understand how you can use your programming to actually make a project and actually finish a task. So again, the idea is no memorization, application. So another reason why AP Computer Science A might be a little bit more challenging in the beginning is because there's a lot of topics involved that are actually quite unintuitive for a beginner. So stuff like classes or polymorphism or binary search or recursion, these topics are actually really difficult for people who have never kind of experienced computer science to grasp their head around. And so that's why computer science A might be a little bit more challenging than computer science principles. So if you're thinking of, oh, which class should I take first? Which class should I take next? I recommend computer science principles and then computer science A, but you can totally just start with computer science A. There's no problem with that. Okay, so the multiple choice. So in the AP exam, it's split into two different sections. So there's a multiple choice section and there's also a performance task section. So the multiple choice section has 40 multiple choice questions and you're supposed to finish in 90 minutes and 50% of that is the score for the entire exam. Now, the most interesting part about the multiple choice is actually, you're not really coding anything, you're mainly tracing and figuring out what errors are in the multiple choice. So a common theme in AP Computer Science A is actually you need to be able to trace your code. So when you have a compiler and you're using an IDE, you're giving the luxury of being able to run it and see and debug and see what kind of errors you have. In AP CSA, you don't have the luxury, everything's on a piece of paper. So you have to be able to trace your code, find the patterns, and that's generally the theme for multiple choice. That's like the hardest part of multiple choice is being able to trace the code and understand what the code does. And the performance task is also a little bit different from the AP CSP. So AP CSP performance task is asynchronous from the actual test itself. So what I mean by that is maybe like a month before the actual AP exam, you're gonna be working in class, creating a project for AP CSP like Ian said. But in the AP CSA exam, you're going to be doing everything in one sitting. So after you do multiple choice, immediately you're going to be doing the performance task for AP CSA. And in my opinion, the performance task in AP CSA is extremely icky because you have to write all the code using a piece of paper. So generally you're writing your code with a keyboard. But in the AP CSA exam, they're going to force you to write it using a piece of paper and pencils and pens. So you need to get used to that. So I recommend when studying for this exam, just try doing the performance task using a piece of paper, using pen, using pencil, and just getting the gist of that because you don't really have the IDE to help you when you're studying, when you're actually working on the exam.
Okay, so let's talk about machine learning and how to pursue machine learning as a high school student. So first of all, machine learning is algorithms with performance improvement as they are exposed to more data over time. And then this generally can be broken down into three different branches. So we have supervised learning, unsupervised learning, and reinforcement. So throughout this journey, you will learn techniques like regression, classification, and clustering. So I recommend Python for machine learning and for the following reason. So first of all, you will have access to strong libraries and frameworks. You get great flexibility and you also get a large community you can learn from. And the most important is that it is very beginner friendly, the Python coding language. And so machine learning, you see it everywhere around the world, every day. From the iPhone you use, the facial recognition. And then you can also see that on the ads you get, advertisement from YouTube or product recommendations, etc. So we have a classic example over here, digit recognition. So imagine how a computer can recognize what you're writing down, even though the pixels are like off by really much. Isn't that amazing? Yes. Anyone here plays Minecraft? Yo, yeah. Okay. Did you know someone actually managed to recreate this entire program inside Minecraft? That's also a fun fact for you. And on the right side, we also have a program that can classify COVID-19 cases. So now here is what it actually comes to be useful. So imagine if we are able to automate this process, we'll improve the efficiency by like exponentially. And then we're saving manual labor, saving doctors' time, etc. And our research team currently is working on a project that can classify human emotions based on their expression, which is, I think, is really cool. There's so many different ways you can learn machine learning. So one example is taking summer programs. So here we got some recommendations for you. And by the way, there are all links you can click on. So you can get the QR code and then scan, and then you can click on them if you're interested. Aside from this, you can also find tons of resources online, like YouTube videos, and you can read books about it. And there's so many things you can do to learn. And you can, one thing about this is the topic of AI and machine learning is really popular, and it really stands out. It is really a good topic for research and studies, because there's just so many possibilities, and we're like using it every day. And this is what college want to see. So here, I got some resources that I mainly use. So we have Kaggle, we have UCI machine learning repository, visual data, and the CMU library. So those are like data sets. So, you know, machine learning, you want to train your machine to learn, you have to use data sets, and those are sources you can use. I highly recommend using Kaggle, because not only you can find tons of useful and great data sets, but you can also find other people who work in the code where you can learn from it and improve your own code and get some inspiration. And here are some libraries you can use, which, for example, NumPy, you use it to do array manipulation. And then we also have sklearn here, where you can use the SVM sample vector machine, and Keras for building neural networks, and of course Panda for loading data set and manipulating variables. And finally, we also have Matplotlib, which is essential because it's in charge of visualization. Always a big part of machine learning.
All right, so we're going to go ahead and start the USA Computing Olympiad section. So I'm going to break down everything you need to know about the USACO. So how are you going to prepare for it? What is it about? And the general logistics of the actual competition. And yeah. All right, so what is the USA Computing Olympiad? Well, the USA Computing Olympiad is, at its core, just an online computing contest for high schoolers. So it's a little bit different from the other competitions. So there's no apps or research involved. It's just straight problem solving. So what I mean by that is you're going to be learning techniques. You're going to be learning algorithms. You're going to be learning data structures and all these cool things to really challenge yourself and build your abstract concept reasoning. And so what I really like about USACO is the problems. Most of the time when you look at the problems, there are some problems where you just have no idea how to start. There are problems that you've never seen before. You have no idea where to begin. But that's the beauty of USACO, because the idea is you're doing these problems over and over again. You're building that foundation, you're building that knowledge, and you're really challenging yourself to pursue these problems no matter how many hours it takes. And each time you go through it, you're building your problem solving skills, and you're really gaining that intuition. So next time you see a problem that you don't know how to understand, you know, okay, I'm going to experiment a little bit. I'm going to manipulate the data. I'm going to find important details. I'm going to do all of that, and I'm going to find a solution that's efficient, that's beautiful, and that really works. And so that's what I want to stress about the USA Computing Olympiad. It's all about perseverance. It's all about practice, and it's all about staying committed to the task. Because you can't really be complacent in this project, because USACO really requires you to build your intuition skills. And when you don't, when you just stay complacent all the time, when you take five-week breaks or 10-week breaks, you're going to lose all that sense. You're going to lose that problem-solving strategy. So if you're really committed to doing well in this contest, I'd encourage you all to spend a lot of time on it, to spend days and days and days just working, no breaks. But that's the best part about it, because once you spend all those hours and you really push yourself to solve a problem, you spend all that much time struggling, and when you finally get that solution, you feel super good inside. So I'm going to break down the logistics of this competition. So there's 4 divisions. So once you register online, if you don't know how, of course, you can go ahead and email us at info@startlineedu.org. I can show you how you can register for the competition. You start as bronze, okay? And every single contest, you have the ability to increase your division. So you start with bronze, and you end up in silver, and then you end up in gold, and then finally platinum. And in this contest, the top 25 USA participants have the ability to participate in the USA training camp, which is basically the top 25 in the entire USA. And out of those 25 people, 4 of them will be able to compete in the IOI, International Olympiad of Informatics. And these are the most talented students in computing in the world. They're the top 4 in the nation, and they're competing against everyone in the world. So if you end up in that area, then you've done a great job. You spent a lot of time, and you definitely deserve it. So every single school year, there's one season. And in one season, there's 4 contests. So the contest generally starts around December, and in January and February and so on. You got 4 contests and 4 opportunities to rank up your division. So let's say you start as bronze when you register for the next season. So on December, if you get a perfect score on bronze, then you're given the ability to actually rank up twice. So if you get a perfect score, then you have the ability to take the silver contest as well and try your luck to pass into gold. But if you don't get a perfect score, then you have to wait until the next contest in the season. So how the contest works is that there's 4 hours per contest, and you've got 3 problems. And generally, if you want to pass a contest, you need to have at least a minimum of 2 problems solved. But even then, that's a little bit of a low ball, because the way they score this competition is using test cases. And so your solution might encompass some test cases. They might encompass maybe 5 or 6, and you get partial credit. But generally, every single test case you get right, you get a certain amount of points. At the end, based on how well overall the participants did, there's a threshold to be passed. And if you pass that threshold, then you'll be able to rank up to the next division. So it's all about test cases and how your solution fits in. Does your solution work only some of the time, or does it work all of the time? That's what test cases seek to find out. And if you get them all right, then most likely your solution is complete and it works. Okay, so I'm going to break down my favorite resource for the USACO. It's called the USACO Guide. And the reason why I like this is, one, it's free. So you don't have to pay any money, unlike all those programs where they force you to spend thousands of dollars to join their program. This is completely free. And it gives literally every supplemental material you can possibly want inside a guide. So whatever videos you want to watch, whatever resources you want to watch, whatever books you like to read, or whatever packets you want to read, everything is there in a really nice format. It gives you a way to track your progress. It sectionalizes the entire guide based on all the different concepts involved. It's like there's one section for DP, there's another section for minimum spanning trees and blah, 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 blah. And the best part of it is it's written by campers and IOI medalists. So the people I was talking about, the top 4 in the nation, these people are writing the guide. So they know what they're doing, they know how you can study, and they're sharing their method of study inside this guide. And so this is what I've been talking about here. So take a look at this UI over here. So for example, if you want to learn dynamic programming, you click on the dynamic programming section. And over here, you have a couple of options. You can choose Introduction to DP, and that gives you a bunch of resources on how you can learn dynamic programming. If you want to learn knapsack DP, which is another concept that will be tested, you can click on that and they give you resources for that as well. So they give you resources in every little sense of concepts that you can possibly want. They also, again, give you a way to track your progress. So if you do well on one, the 0 out of 89 will become 1 out of 89 and so on. And generally, they also tell you how frequently these concepts are being tested in the contest. So for example, Introduction to DP, that's very frequently tested. So you should keep in mind to actually study that topic if you want to pass. And another example is longest increasing subsequence over here has not ever appeared. So if you want, you can skip that because it's not ever appeared in a contest and you don't really need to study it. So they even give you extra information if you're just curious about expanding your abilities as a competitive programmer. So again, resources, there's so many they give you. So if you don't like resource 1, if you think resource 1 is extremely confusing, then look at resource 3, look at resource 2, look at resource 5. There's so many resources for you to choose from in the USACO guide. I think this is great. It's completely free. You don't even have to register to access these. It's completely free. You have access to YouTube videos. You can have access to packets and books and all of that in one website. Just go ahead and take a look. It's completely free. If you want to do well, then I'd encourage you to look at this website. Okay, additional resources. So these are some other resources besides the USACO guide that you can use to prepare for the competition. So one of the most popular programming languages for the USACO is C++. And so one of my favorite YouTube channels to learn C++ is someone called The New Boston. And they do a very good job breaking down how C++ works. They speak in a very simple, concise manner. They give funny and humorous examples. And I personally think if you want to learn C++ all the way to the level of a USACO programmer, then I would encourage you to take a look at the New Boston channel. They do great things there. And there are other examples. There's a guy called Karara who does a great job breaking down USACO concepts. And there's an AlphaStar YouTube channel that I found that actually gives you some solutions to how to solve these problems. So if you're a guy who doesn't like reading the solutions, you like visualizing and seeing how someone else breaks down the problem and solves it, then AlphaStar and Karara, they're all good resources. And for classes and materials, one of the ways you can learn C++ as well is through our organization, Starline Education, where we actually teach C++ to the full. So we go from variables and all the way to vectors and different data structures. You can learn it all in our website as well. I've also included a link to the USACO guide. I've also included a link to something called Code Forces. Now, Code Forces is a great resource because it's also competitive programming. You're actually also doing a bunch of problems. But the difference is that the problems are generally more shorter, but they still test you on similar things. They still force you to think outside the box and think creatively and do some more unique stuff to get your answer. And of course, I've also added in C++ reference, another way you can learn C++ and get yourself to the next level.
And so now I'll be talking about robotics in high school and what you can do to further yourself in it. So there's a lot of benefits to taking robotics in high school. It's really great for developing problem-solving skills, whether you're wiring the robot, having a model, or coding it. It's a great way to work on your skills. And this also gives a lot of great hands-on experience. If you're thinking of going into a STEM-related field, it's a great way to figure out what kind of robotics-related or STEM-related things you like, whether you want to do CADing, or you want to do coding, or you want to do machining. It's a great way to learn what you're good at, or if you're not good at it yet, work on improving it. And it's also a super great way to make connections with people, whether it's your teammates or your mentors or people you meet at competition. It's a super great way to meet people and make friendships and get advice on where you want to go, and maybe even advice on what to do once you've graduated and where you can work in the field. And the best way I think of getting into robotics is through the FIRST organization. They're an organization dedicated to spreading and helping students and kids to get into robotics, from their Lego League for pre-K to 8th grade to their FRC for high schoolers. It's a really great way to get in. And there's over 9,000 teams, and actually team 6560, the Charging Champions, is an Irvine-based team. So I recommend you guys check them out. Here's an example of one of the top robots in the 2022 Rapid React game, performing one of the tasks. And now we'll also talk about some additional competitions in robotics and CS. Like I've mentioned, the first competition, they will create an arena. They'll create schematics for an arena and build a couple, create a rule book and tell all the teams what kind of robots you can build and what tasks you need to do. And then you'll have this happen, they tell you in January. And then you'll have a number of weeks to build a robot. And then what the first organization will do is they'll ship off the arenas to be assembled at locations all across the US. For example, there was a regional competition. There's the Orange County regional competition. There's the Los Angeles regional competition. There's the San Diego regional competition, and that's only a couple. And the teams from nearby will gather at these regional competitions, and they'll compete to win and see who's the best. And then if you win at one of the regional events, you get a ticket to go to the Houston championship, where you play the same game with all of the other people who won regional events to figure out really who's the best. And it's super fun. But one of the things is the first organization only hosts competitions from around January to April. So during the rest of the year, well-established teams will get arenas, and they'll host their own independent competition. of the game. For example, and as an example of independent competitions close to Irvine, there's Beach Blitz and Bots at the Beach, which I heavily recommend you check out. If you can figure out whether FIRST is the kind of robotics program you want to go into and whether you want to join a team.
Okay, so these are additional competitions for CS. The first one I'll be going through is the Congressional App Challenge. And basically what you do is you're going to build an app doing whatever you want. It's going to solve a problem. And you're going to submit it to the Congressional App Challenge. And what they're going to do is they're going to evaluate your app based on maybe its potency, how well it's designed, or its potential uses, or anything of that sort. So if you want to just build an app, you can use machine learning for this as well. You can use whatever you want. Just figure out a problem, make an app to solve it, and then go ahead and submit it and just test your luck. And so another competition I really want to stress is the AMC 1012, AV, and USAMA. So these are math competitions that are kind of congruent to the USACO. So the math Olympiads, there's a very nice connectivity between math and computer science. So having a strong math background in computer science is definitely a really nice thing to have. So you start off with AMC 1012. If you don't do well on it, you can qualify for the AV. And after you qualify for the AV, if you do well on that, you also get into USAMO, and that gets you into their own training camp. After the training camp, you can be a participant in the IMO, so the International Mathematics Olympiad. So if you want to have that creative problem solving for mathematics as well, I'd recommend that. And there's also casual competitions where basically you'll be doing data science competitions. And the interesting thing about this one is you're actually earning a lot of money. So there might be competitions here if you're interested, where if you win, you can get thousands of dollars. So if you're interested in that as well, then I'd suggest you click on this link. There's the QR code there. You can scan it. There's slides over here. Just take a look at all the links and just explore around. If you want some more resources, we'll be more than willing to give you some. Just email us, and then we'll just give you a bunch of resources. We're here to give you as many resources as you want. ISET is another one. ACSL is another one. These are all really great competitions for you to just explore and try to see which one you're interested in. And there's just great ways for you to pursue CS to the fullest. Yeah, so here is our question and answer section. So if you guys have any questions, raise your hand. And for the Zoom, people in Zoom, just put your responses inside the chat, and we'll monitor that as well. If you want, you can also unmute. Okay. Oh yeah. Yeah, so I use C++. I really like C++, but Java is also works. So I recommend C++ and Java if you want to go to the higher divisions. So for bronze, Python is you can use Python because you don't really have to worry about efficiency. But once you get into silver and gold, they stress more about efficiency and time complexity. So you want a low-level programming language that's a little bit faster than Python. So at that point, I suggest C++ or Java.
For Jay, who asked in the chat, is math helpful for computer science? Yes, it's very helpful. Math is really tied in a lot with CS, and it's it's really good to have a solid math background if you want to do CS.
What's your ideal recommendation for that pathway in high school?
I recommend at least taking Calc BC, right? But then if you want, you can go even further to college classes. So I know if you want, you can go ahead and do linear algebra and IBC. These are great ways where you can actually increase your math experience as well. But again, AMC is also a great way to show the colleges like, hey, I'm really good at math as well.
For Harry, how far does your coding skill have to be to take these competitions? Do you have to be in AP Computer Science A?
Okay, so you don't really need to be an AP Computer Science A. You can learn the languages on your own, honestly. So you don't really need a class to teach you how to learn the language. But generally, if you want, you can just go online. There's a bunch of tutorials. There's a bunch of websites for you to learn and develop your programming language. So for your question, how far does your coding skill? Okay, so at least for USACO, you should be very, very comfortable with one language. Because if you're not comfortable with one language, then applying it to these problems, at this point, programming becomes a tool. It doesn't become something that you memorize. So you need to have a very comfortable level with your coding skill in order to do well in at least competitions like USACO. I'm pretty sure Ian can also elaborate on how that translates to robotics as well.
Yeah, if you want to do coding in robotics, it's usually most people use Java, but also there's mentors to help you, so you don't really need to go in with all that much coding experience. You can almost learn on the fly from your teammates and mentors. From Jevin, how long did it take you to get to USACO Platinum?
So I started around freshman year and I qualified junior year, so maybe around 2 years-ish.
And then from Chang, what is the best programming language to use for competitions?
For USACO, again, like I said, C++ and Java are both great programming languages to use in USACO. So for robotics, Ian said Java.
Yeah, most teams will use Java.
And for machine learning, Jackie said Python.
Does anybody else? Do you have a question?
Yeah. Can you say that again? So are you talking about USACO?
Yeah.
Okay, so of course USACO has like previous competitions you can just look for, right? Another resource I can give is like I said, Codeforces, right? Codeforces has a bunch of problems there you can go ahead and check out. If you just search online, there's a lot of different competitions that's very similar to the USACO in that you're using like algorithmic thinking rather than something like robotics. So there's a lot of websites out there you can just check out.
And then from Z Chen, are the problems on train.USACO on the train.USACO website worthwhile?
So they're a little bit outdated. I honestly didn't use the train USACO website that much, but since I didn't really use it that much, you can go ahead and try it. I'm not sure. So I'm pretty sure they're a little outdated though, but there's the USACO guide for your reference. I think that's the best resource to use if you're studying for USACO.
And then from Ted, how much time do you have to put into coding every day to get good at it? Well, you don't really even need all that much time as long as you're making sure that you're coding outside of your comfort zone, trying new things and learning. It's a really great way to expand. And so I wouldn't really be able to put a time on it, but it doesn't, as long as you're consistent, it doesn't need to be all that long. From Fang, what is your math pathway in high school? What math course do you take from 9th grade to 12th grade?
So for IUSD, generally, like the accelerated is you start off as enhanced math 2 for 9th grade, and then enhanced math 3 for 10th grade, and then 11th grade, you take calculus, AP, Cal, PC, or AP. And then 12th grade, if you want, you can go ahead and take college classes in IVC if you want to just go above and beyond. But there are some people in middle school, when they take that test, they're able to jump into enhanced math 3 for the freshman year of high school. So for everyone, it's a little bit different for IUSD. I'm not sure about private schools though. That kind of stuff is only, I guess, private for them. So
yeah, and also if you finish up calculus in junior year, there's statistics that you can take, and I think that I'm not sure if there's any other classes, but you can take a year of math every year and stay in the high school.
Yeah, math is pretty important, guys. I think recently Cornell actually said that for their College of Engineering, one of the recommendation letters you need has to be strictly from a math teacher. It's not computer science A, literally a math teacher. So colleges are starting to stress math a lot more for computer science. So just keep that in mind.
And from Judy, is boombot a good robotics program for middle schoolers to start with? I can't say I have any experience with a boombot. I I started off with robotics, such as Mindstorms when I was in elementary school. And then I hopped into FIRST when I was in high school. So I'm not entirely sure about boombot, but I don't know. What's the most used coding language in competitions?
For USACO, I'm fairly certain that it's C++. Yeah. So depends on how committed you are. And it also depends on like just how fast you are. There are some people I know who got into platinum in 3-4 months. They're very talented. There are other people who take 2 years. So it just depends on how dedicated you are to actually doing well in the USACO. Yeah, so for bronze, Python is okay, but once you get into silver and gold, I totally recommend you switching to C++ or Java.
Efficiency problem.
Yeah, from Jarrett, how do you prepare for AP CSP? How long does it take to prepare the test? How many hours do you spend on CS related studies and activities every day? So for AP CSP, it is not quite as challenging, and it's also a lot more, the topics are a lot more varied. So I'd say a good way to prepare is to look at what the College Board requires and make sure that you're familiar with all the topics they cover, like the digital divide, DNS, internet protocols, and also make sure that you're paying attention in class and that you know that you are proficient enough in the basics like iteration, loops, storing variables in lists. And I'd say you don't really have to spend very long daily on CSP. It's a pretty simple class, and as long as you can understand the concepts, you don't really need to memorize all that much stuff. From Ted, can you tell me the same thing about AP CSA? So how do you prepare for AP CSA?
So it depends. If you're self-studying, then obviously the best thing to do is know Java down code. So go on YouTube, go on other resources, just search up Java. Okay, the most important part is understanding Java. And another theme, like I stressed before, is tracing. So the ability to trace through code, the ability to be able to understand what the code is doing without using a compiler. So that is another important step. And how long does it take to prepare for the test? If you're very strong with Java, if you know all the little nuances and the little details, you don't really need to prepare at all. But if you're not strong with the language, then you definitely have to prepare. And how many hours you spend in this related studies and activities every day. If you want to do USACO, it depends. Just do as much as you possibly can if you're really dedicated. But if you want to spend 3 hours, 4 hours, 1 hour, 2 hours, anything is better than just like not doing anything. So
right. And how many hours would you say should you put into coding if you're just looking to get a good score on the AP CSA?
Honestly, 30 minutes a day, maybe, if you're not comfortable with the language, but just being comfortable with the language and understanding little nuances, little details of Java should be enough.
Yes.
Compared to USACO, what level would
Very, very easy. So USACO is significantly harder. Java is basically testing you on like how to use a language. USACO was testing on, okay, how do you use a language to solve really difficult and challenging problems? So it's worlds apart.
Anybody else with questions?
Anyone else on Zoom have any questions?
Oh, yes.
Yeah, good question. So I started with Python first, and then as I got deeper into USACO, I was like, okay, let's just try studying C++. So when I went to do C++, then I was able to do well in the competition. So I started off with Python, but people, if you want, you can start off with C++. It's just a little bit more challenging than Python because C++ is a lot less intuitive. Like for example, Python, you can have to do like print. Yeah, exactly. It's confusing, but if you want, you can start with Python first and kind of understand how all the programming languages work, and then transition to C++. Because if you understand one language, transitioning to another language shouldn't be difficult. Yeah, Java, same thing. You can use Java for USACO as well. I just prefer to use C++.
Did you have a question?
就是我有个问题啊，我想问一下，就是你每天那个在练习的时候，就是用的是那个free 的网站，还是专门练习的？就是你刚才设的一些网站。
So when you practice daily, daily coding, do you go to a website or something?
Yeah, so one of the best ways is doing practice problems in the past. So like looking how the different problems work in the past is the best way, in my opinion, to study. So just being able to understand what kind of problems they're offering you and how you can approach those problems, that's the best way.
Where can you find those? Is there a website where you
Yeah,
can find
this
those?
is the USACO website. I actually linked it inside the presentation too. So you guys, yeah. Oh, yeah.
So like I know usually I can start about the
Yeah.
I know like the task is like a little bit different. So if you want to practice like a level cycle, where can you find it?
Yeah, USACO Guide. They give you all the they give you so many websites and so many different problems. So USACO Guide is the way to go. I've also linked it in the presentation. They give you virtually every single resource you need. Yeah. What?
Oh, the QR code. Did you have more questions? Okay.
Yeah.
So is also is there a certain extent because I know you can
Yeah.
They're like how do you know you see with programs and like libraries and apps?
So in USACO, there's something called like include and embeds std++.h. So if you want, you can just study that and you just basically include it instead of just importing a bunch of different things. So that includes different data structures like sets and maps and all of that good stuff. So there's just one import generally, but sometimes there can be more.
Any other questions?
从那个 Python 到学 Java 或者 C++，这个转换的时间需要很长时间，还是很快就可以适应？
How long would it take to transition from Python to Java?
Python to Java, not very long. Because if you understand how the programming language works, then transitioning is easy.
Yeah, it's mostly I moved from another program over to Python, and once you understand how coding works, it's not really all that difficult to transfer between programs. It's just remembering the little nuances of each program that's difficult.
这个另一个就是跟这个学术方面，就是直接相关，就是在学这个 coding 的过程中，因为大部分的孩子可能这个他需要一个 self control 的一个过程，就怎么样去平衡玩那个 video game 啊或者其他方面的。那我想请问一下，就是Calvin他是怎么样去有没有在玩 video game 啊 C# 有没有在学，或者怎么样去很好这样去在玩和学习之间去。我相信大部分的爸爸妈妈或者是孩子都面临一样的挑战。
How do you balance between playing video games or having entertainment and studying?
So I didn't really see USACO as studying because I genuinely thought it was fun. So at first it's really hard, right? It's really hard to just persevere through these problems. But at the end, trust me, when you solve these problems, they're super difficult. But at the end, if you get them right, you just feel really good. Because all that hard work and you finally got a correct solution, I kind of chased that feeling. So I never really thought of it as a burden. I never really thought of it as, I'm just gonna spend 2 hours in this and just play video games. Sometimes I lose track of time on how long I'm spending on USACO. So I actually do find some entertainment in USACO. So I didn't really have to think about I'm balancing video games or watching YouTube and all of that.
coding is like a rewarding activity to do, and it's kind of addictive, to be honest.
刚才那个补充一下，请问那个 Kevin 现在有没有在学那个 C#？
Are you learning C#?
I've never wrote in C# before.
Any other questions on Zoom? Oh, Morgan, how do you spell the website again?
So which website, USACO or? Yeah, so usaco.org.
He's going to type it in chat. While you're doing that, any questions in the audience?
Oh, sorry, I direct messaged that. My bad. All right. Yeah, so that's the link.
Is there a good website to directly serve Python functions as opposed into a? Okay, so you know how most of Python functions and NumPy are coded in C or C, but is there a way? Is there a website to tell you how to directly make those functions? For example, there's a log function in Ap. Like, is there a website to tell you directly how to make that log function in Python?
Yeah, so I don't know a direct website for that, but the answer would be Google. So yeah, I'm not joking. Every single time I don't know how to do a topic, I just search it up on Google. So I don't really know any specific website that's better than USACO Guide. If you can't find it there, then just search it up on Google.
A great way to learn coding is whenever you encounter something that you don't understand, it's guaranteed that somebody else has had that question and asked it first. So just looking up that question, you'll most likely get a dozen answers that will help you out.
Oh,
那个冒昧的问一句 ，Kevin 现在是升12年级还是12年级
Already top grade. 他已经12年，现在就12。
就现在刚刚是12年级，我们有什么？
Any last questions from Zoom or from anyone?
Yeah.
Yeah, okay.
Anyone else or? Okay, if anybody has any last questions they think of, feel free to approach us after and ask. We'll be happy to answer.
Yeah, thank you guys all for coming today.
Thank you.